Good morning.
Good morning, Mr. Strong.
Okay, so let's see. We've got in Holbrook. Let's see, Jocelyn, I thought you were going to be gone.
We barely got back.
Oh, okay.
We got done 10 minutes earlier, but I did see Jill there.
Oh, okay. Oh, yeah, Jill's back. Tara's back. Jocelyn, Jill, and Raylyn all back. Wonderful. All right. Is there anybody missing in Holbrook? Looks like everybody's there. Looks like we're missing.
Sierra's not here.
Oh, Sierra. And then Jay.
Yeah.
He's not here.
Okay. All right. So a couple things. First of all, so during class time tomorrow, you will have a part 1 of the midterm. Part 2 will be on Thursday. Okay, what's different about the midterm? Well, there's 2 things. Number 1, you only get 1 attempt. And number 2, there is a time limit. Well, there's kind of been a time limit on these other ones, but not like this. So there is a 60-minute time limit on each part. And you only get 1 shot. Let's see. Also, so a lot of you have, been sending requests to take second attempts at this and that or the other thing, quizzes, tests, and that's fine. Okay, remember that all of that has to be done by when you take the part 2 of the midterm. Okay, so if you want to do any more attempts or make up any quizzes or anything that you've missed or want to improve your grade, it needs to be done by Thursday noon. Okay, you need to have that done. Okay, so any questions, concerns about that?
You said that the midterm covers up to 8.2, or is there?
Well, I'm actually after class today. I'm going to go through and see if we have enough. See, I don't know how many questions we're going to have, because some years there's 5 minutes of questions or no questions at all, and then we're able to go and we could finish 8.2. In which case, I will leave those questions on there. But if there's enough questions from chapter 6 and 7 and we're not able to finish 8.2, then I'm going to go take those off. So I've actually looked, and there's some questions that were on from 8.3. So I actually know I'm going to take some questions off right now. And so initially we had I think last year we had 25 questions on the midterm part on each part. And so I'm going to cut that down to 20. Okay. All right. Any other questions? Okay. So
there's 20 questions on the total? No. On each half.
There's 20 questions for each part. So, but frankly, let's see, I did kind of a breakdown. I think there's like 9 of them that you should take less than 10 seconds on. There's 9 of them that I call quick hitters. So if I ask you, what's the inverse sign of radical 2 over 2? You should know that. Or you should be able to find it on the unit circle. That should not take you any time at all. Okay, just a matter of seconds. But if there's one that says solve this trig equation, then see, I'm thinking that's going to take you time. But so there's like, of the 20, I think there's like 9 of them that are quick hitters, and then 11 of them that are just regular problems. Okay? All right. Okay, so let's do this. So again, I've got 8.2 loaded up or whatever, but if we cover all of it or none of it, I'm okay either way. So does anyone have any questions on anything from chapter 6 or 7 that you'd like to review? Now, I don't want you to ask me how to do a specific problem on a test, because there's still people that are wanting me to open up the second attempt for chapter 7 test or something. So don't ask for a specific question from a test or a quiz, but anything you can find in your book or anything, that would be helpful. Okay.
I have a problem from the book. Can you
Okay.
do number 18 on page 543?
Okay, 543. Number 18. Okay. Okay. All right, so this problem says, solve the following problems, round answers to the nearest hundredth. A gear in a machine has a radius of 14 centimeters and is rotating at a constant speed of 600 RPM. Okay, so really the first thing I want to talk about is what does RPM mean? What that means. And it means revolutions per minute. Okay? And so one revolution, if you're converting that to an angle, one revolution is 2 pi radians. Okay? Okay, so find the angular speed of a tooth of the gear in radians per minute. So it's asking us to convert revolutions per minute to radians per minute. So you kind of multiply and say 600 revolutions per minute times 2 pi radians for one revolution. And then the revolutions will cancel, and so you'll get radians per minute. And so basically it's just 600 times 2 pi, or 1200 pi radians per minute. Okay, then part B says we want to find the linear speed of the tooth in meters per second. Well, you might remember once you have the angular speed, to get the linear speed, you just multiply by the radius. Okay? So if we take our answer to part A, and see, these are the formulas that we did back in chapter 6. And so the angular speed was the angle over time, so like 1200 radians per minute. So to get to the linear speed, you just multiply by r. So the radius here is, it tells us in the problem, is 14 centimeters. But it actually says in the problem to do it in meters per second. So instead of putting in 14 centimeters, I just put in 0.14 meters. And then, and let's see. Oh, and we were in the other thing with the units. Oh, it says meters per second. So we were in radians per minute. So we need to convert 1 minute into 60 seconds. And so then the minutes cancel, and so I end up with meters per second. So I would take 1200 pi times 0.14 and then divide by 60. And that would give me the answer in meters per second.
All right, thank you.
You bet. So any questions on that? Oh, there's Jay. Hello, Jay. All right. Does anyone have another question on anything?
Yes. Can you do number 3 on page 601? It's in the chapter 7 review.
Okay, page 601. Number 3. Okay. All right, so all right, it says use trigonometric identities to simplify the expressions. There may be more than one correct answer. So we have tangent of negative y over the cotangent of x of pi plus y. Okay, so there's a couple of things that we want to look at here. So when we have a negative angle, we want to take care of that right away. So what we need to know is does the negative come out front or does it disappear completely? And so what you look for there are your even and odd identities. Okay, now you might have those on the paper with all the identities. I'm going to just show you where they are in the back flap of the book, the second column, almost halfway down, even odd identities. So it says the tangent of negative x equals negative tangent x. So that means the negative has to come out front. Okay? So let's take care of that. So it's going to be negative tangent y. All right? Now, the next thing we want to do is take care of this pi plus y. So when we add pi or a period, to take care of that, we want to look at the period identities, which is right above that on the back flap. So the period identities say the tangent of x plus pi is equal to tangent x. So when you add a period to a function, you're not going to, and cotangent in the period is pi, so we basically can get rid of the pi. Okay? So that's what we want to do. So this is just going to become the cotangent of y. Okay? All right, so whenever we have a negative, we can take care of that with the even odd identities. When we're adding in a plus pi or 2 pi, we usually take care of that with the period identities. Okay? All right, so now, the next thing I think to do with tangent and cotangent, well, cotangent is just the reciprocal of the tangent. And so if a cotangent 1 over the cotangent is the same thing as another tangent in the numerator. So I could think of this as negative tangent y times tangent y. And so that would be negative tangent squared y. And that's where they have it. I mean, you maybe could break it down to sines and cosines, but nothing's really going to cancel from here. So that's a good answer right there. Okay. So we had, so first this was the even odd identity. Then we needed a period identity. And then this last one was a reciprocal identity. Okay. So that's why I would suggest, when you're doing this test, number one, it helps to practice. And I'm really happy that you guys are obviously working on practicing these reviews. The second thing is it helps to know where stuff is. So have your guided notes ready. And if you know kind of where formulas are in the book, that will help you too. Okay. All right. Next question.
I have one on page 604, number 1 on the chapter test.
Okay, 604, number 1 on the chapter test. Okay. All right, so it says use trigonometric identities to simplify the expression. There may be more than one correct answer. Okay, so we have sine squared negative x minus 5 secant squared x cotangent squared x. Okay, so let's start with the even odd identity. So the sign of negative x, does the negative go in front or does it go away? Or could someone tell me why it's not going to matter?
Because it's squared?
Because it's squared. So even if it goes in front, or if it disappears, when you square it, it's going to become positive. Okay? Now, it actually does go in front. So I'm going to write it as the negative sine of x and then square that. But see, when we square it, even though it's negative, it's going to go away. So this is just going to become sine squared x. Okay? Now, all of this over here, I'm going to just see if maybe anything will cancel. So let's write it in terms of sines and cosines. So minus 5. Okay, so what is secant in terms of sines and cosines?
1 over cosine.
1 over cosine. So this is going to be 1 over cosine squared. And what is cotangent in terms of sines and cosines?
Cosine over sine.
Right. So do you see the cosines are going to cancel? So this is going to be cosine squared over sine squared. And so now the cosines are going to cancel. And so what I'm going to be left with is 5 times 1 over sine squared. All right? So now what is 1 over sine squared? What's the reciprocal of sine?
Cosecant.
Cosecant. So let's write that as cosecant squared x. All right, let's see if that's how the book has it. Yep. So that's as far as they want you to do.
Okay, thank you.
You bet. So even odd identity to take care, whenever you have a negative, is the argument of the trig function. Look for those even odd identities to know what to do with the negative. Okay? And then, just as far as simplifying, then that's when you use the break it down to sines and cosines, find a common denominator, factor and cancel. You use a trig identity. See, in my mind, I'm thinking about all those things that I might have to do here. But so with this one, as soon as I broke it down to sines and cosines, stuff canceled. So that's good.
Professor Strong, how do you
Yes.
know when to stop simplifying?
Now, that's a great question. And the answer is, for the midterm, you look at the answers and see if yours matches. Okay? All right? So, but yeah, that's why I like the ones that say on the homework that say verify the identity, because then you know where to stop. But see, the problem is I can't really, I can't put that as a question on the midterm. Verify the identity, and then you say, yeah, I did. Okay, then how do I ask that? So it's more like this. And so you would look, see if this matches one of the answers. And see, I wouldn't have answers where they're all right, just simplified more. The wrong answers would be wrong. Okay. All right. Another question.
Can you do number 27 on page 606?
Okay. 606, 27. All right, you said 27 or 26?
27.
Okay, thanks. Okay. So these big exponents, they're just to frighten you. Okay?
Well, I'm pretty sure I know how to factor that, but the answer that's in the back of the book was just really, really weird, and I'm
Okay.
not sure how I got it.
So let's see. Okay. Yeah, that is a weird answer. All right, so let's set everything equal to 0. All right, and then how did you factor, Lauren?
You can take out a 2 cosine to the 6.
And then you're left with cosine squared x minus 2. Okay, so now we set each factor equal to 0. and then solve. So here, divide each side by 2. And then take the 6th root. Okay? We don't do that very often. But the 6th root of 0 is just 0. So this just gives us cosine x equals 0. So what values are going to have a cosine of 0?
90 degrees and 270 degrees.
Okay. All right. And then over here, we get cosine x equals 2, cosine squared x. So take the square root of both sides. Cosine x equals plus or minus the square root of 2. All right, so what's the problem with that?
It's not on the unit circle.
And that's one problem. What's another problem? Anybody try putting it in the calculator? The inverse cosine of radical 2?
There's a domain error.
And why is that?
It's not in the whatever it's called, interval or.
Yeah, cosine lives between -1 and 1. That's the range. And so if you get an answer over here that's bigger than 1, which radical 2 is, or less than -1, which negative radical 2 is, then this is going to give you no solution. Okay? So our only answers then are 90 and 270. Okay? Now,
Can you explain the answer in the book then?
Sure. So what they're doing is saying, okay, so that would be, so they've got it in radians. So that's pi halves plus, and then it's multiples of pi. So it should be, okay, let me go back. So in radians, this would be pi halves and 3 pi halves. Okay, or if you want to list them all, it would, forever in both directions, you could say pi halves plus every multiple of pi. So that would be plus n pi. Now, what they're, the way that they are doing it is, they're writing it as, n pi over 2, where n is odd. I think that's ridiculously complicated. If you understand my answer, then you're fine. It's equivalent. It's just, I don't know why they wrote it like that. So I totally get that. But it's the same thing. Okay? So thank you for that question. Is there another one?
Actually, I want to do 26 on that page, if you could.
Oh, you know what? Before I go on, okay, let me remind you that on these trig questions, on when there's ever an equation, you should always get that every time, okay? Because if you get stuck, you can put it in the calculator. All right. So would anyone like me to demonstrate that? Or is just reminding you enough? Anybody, you want me to put it in there? Okay. So let's put it in the calculator. All right. So probably the easiest way to do it is with intersection. So I'm going to put it in the left side in for y1, the right side in for y2. Now, when I'm plugging in trig functions, you need to make sure that you're in radian mode. Okay, so check that first. Okay, so now we've got, it's just 2 cosine to the 8th x. So 2 cosine x. Now you got to be a little careful here because the way the calculator has you do it. So here I'm closing off the argument x, close off the cosine, and now raise that to the 8th. Okay? So that's how you write cosine to the 8th x in the calculator. All right, so now similarly on the other side, for the y2, it's going to be 4 times, okay, so we're going to raise that cosine to the 6th. So open parentheses, cosine to the x, or of x, close off the x, close off the cosine, and then raise that one to the 6th. Okay? All right, any questions so far? So then I'm going to just graph it in standard viewing window. See if I can get an intersection here. This is a little trickier than most because it's kind of hard to see if they're intersecting or coinciding. So let me zoom in a little bit. Let's do zoom trig. And so see what it's doing, it's actually hitting every pi. So let's just find this first one. So if we do second calc intersect, okay, so first curve, second curve. So for the guess, I'm going to just arrow next to the point that I'm wanting it to find for me. So this point right here, that's my guess. Whoop. Okay. Let's try that again. Whoops. Intersect. Wow.
Yeah, I'm getting an error on mine too.
Huh. Well, that's the first time that's ever happened to me in trying to calculate to solve trig equations. And I'm not sure why that's doing that unless, because usually the sign change isn't required for an intersection. Let me do it. Okay. Let's go back to the graph. So let's say if you're not, you're wanting to check it. So what we got was that the answer was at pi halves and then every pi after that. So what we could at least do this. We could do trace and then plug in pi halves. So second pi divided by 2. So at pi halves, And see, we can see that's the point of intersection. So you could at least use the calculator to check your work. I'm not quite sure why it's not actually giving us the answer. That seems a little bizarre to me. But at pi halves, and then at every multiple of pi, so let's verify that. So the next one would be at 3 pi halves. So if we do trace 3 pi halves, so 3 pi halves, and press enter, then see that gives us to the next point. And so we can at least check our answers to, see.
Well, and when it's multiple choice, you can kind of just do that with every
Correct.
answer and see which one works.
That's true. That's true. Whoops. Okay. So, any questions on that? All right. Okay, is there another question?
Page 601, question 5.
Oh my god.
Page 601, number 5. Okay. All right, so there, it says we're simplifying this one. So we have sine squared secant squared theta minus cosecant squared pi halves minus theta plus sine of negative theta. Okay, so once again, when we see the negative theta here, you're going to use an even odd identity. Okay? Then when we have the pi halves minus theta, well, that's not really a period. So we'll take a look at that one.
I think that one's a co-function identity.
Yes, co-function identity. And then sine and secant, we could simplify that. So let's kind of go here. So sine squared times secant squared. Well, secant squared is 1 over cosine. Okay. Then this, when we have 90 degrees or pi halves, that's going to be a co-function identity. So the cosecant squared of pi halves minus theta is just secant squared theta. And then the even odd identity, if I have a negative in here, it comes in front. So minus sine theta. All right, so now this is tangent squared. Sine over cosine is tangent. And then what's tangent squared minus secant squared? Using the Pythagorean identity.
1. Right?
It's actually going to be -1. See, because it's tangent squared plus 1 is secant squared. So to get tangent squared minus secant squared, I need to move the secant squared to the left and then the 1 over here to the right. So it'll become -1. So then I end up with -1 minus the sine. Oops. So tangent squared minus secant squared is going to be -1, and then -1 minus the sine. I think that's as far as we go on that one. -1 minus sine theta. So we have reciprocal identity and quotient identity. co-function identity, and even odd identity. So using 4 identities there in one problem. So you need to be practicing so that you can handle these. Okay. All right. Any other questions on this one?
Can you do number 4 on the same page?
Sure. Okay. So here, again, usually when you have more complicated stuff in here, you want to work on that first. So here, this is going to be a co-function identity. This is a period identity. Okay. So what's the cosecant of pi halves minus alpha? What would that be equal to?
Secant?
Secant. So this is going to be tangent squared alpha over secant squared alpha. Plus, okay. Now, how about, okay, this period identity, the secant of alpha plus 2 pi, what is that going to be?
Secant?
Secant of alpha. So the adding the 2 pi doesn't change it. Okay. All right. So now there's a lot of ways that we can approach it from here. Let's see. Who asked for this one?
I did.
All right. So what would you think to do here?
I combined them together.
Okay.
Like
How'd you do that?
tangent plus cosine divided by secant.
Oh. So you got a common denominator?
Yeah. No.
Okay. So let's try that. Okay. So to get a common denominator, I'm going to multiply this second fraction by secant alpha, because see, this has secant squared. So to get a common denominator, I'm going to multiply numerator and denominator by secant alpha. Okay. And so that gives me a common denominator of secant squared, which is what I want. To put them over secant squared alpha. So in the numerator, I'm going to get tangent alpha plus, so cosine times secant. So we've got it together there. Okay, anybody see anything else we could do?
Can you cancel the secants on the numerator and denominator?
Like this secant here with one secant here?
Yeah.
So if I add 1 plus 3 over 3, can I cancel the 3's?
No, but that one is being multiplied, isn't it?
Yeah, but it's not a factor. See, we would have to factor it out.
Okay.
I mean, it's just like if I had 1 plus 3x and the 3 is multiplied, I still couldn't cancel the 3's because it's not a factor of the whole thing. Okay? But that's a good thought. So what else? Any other ideas?
I have a question.
Okay?
So, why isn't the tangent squared anymore?
Oh, because I left it off.
Oh, okay.
My mistake. Thank you. Okay? So that was a great question. All right. So what else? Anybody else have an idea of what we could do? Go ahead.
Can you do the quotient identities, like the tangent x equals?
Okay. I'll tell you what, before we do that, I'll tell you something that I see right away. When I see cosine times secant. See, what is secant?
It's the reciprocal,
It's the reciprocal of the cosine.
so it's just
So
one.
here, so let's come over here. See, if I have cosine alpha times 1 over cosine alpha, what is that going to simplify to? Just 1. Just 1. So that will make life a little bit easier. And so then this is going to become...
And then
So-
can you change the secant squared x to the tangent squared x plus 1?
Yep, okay, you're way too fast for me. Okay, hold up. So tangent squared alpha plus 1 over secant squared alpha. Okay, now say it again.
Can you change the secant squared x to tangent squared x plus 1?
Yeah, so actually, let's do it the other way. Let's do it the other way. So tangent squared plus 1, let's write the numerator. Let's see, where am I? Yeah, let's write the numerator, tangent squared alpha plus 1, as secant squared alpha. Because then that will make it easier to see what we do next. See, then we have secant squared over secant squared. So the final answer is
1.
1. Okay? All right. So that was a good one. That we used a lot of identities in that one. Now, when you said to get a common denominator and add them, see, I was actually thinking of something else. But I was curious to see how you would do it, and the way you did it was perfect. Okay. All right. And any other questions?
Thanks.
Page 602, 21.
Page 602, which number?
Keep one question
21.
going, guys. Class.
21. All right. It says find the sum or no. This says use the sum or difference identities to determine the exact value. Okay, so here we have the tangent of pi minus 2 pi thirds. Okay, so to find the exact value. So what we're going to do is we're going to need the tangent of u minus v formula, sum and difference formulas. So the sum and difference formulas are on the back flap. It's this column right here, sum and difference identities. So for tangent of u minus v, I'm going to use this formula right here. So I'm going to write it down. So the tangent of u minus v is equal to the tangent of u minus the tangent of v divided by 1 plus tan u tan v. So what I need to do is to get exact values from the unit circle of the tangent of pi and the tangent of 2 pi thirds. So let's do that next before I start plugging in. So the tangent, because I'm going to let pi be my u and the v be 2 pi thirds. So I need the tangent of pi. So what's the tangent of pi? So at 180, the sine and over the cosine.
It equals 0.05.
No.
This is
So
0.
the tangent of pi, if you look on your unit circle, see it's the sine of pi, which is 0, over the cosine of pi, which is -1. So what's 0 over -1? That's 0. Okay? And now what's the tangent of 2 pi thirds? Or that's going to be what, 120 degrees on your unit circle. So what's the sine of 2 pi thirds? Or 120 degrees from your unit circle.
The sine is radical 3 over 2.
So radical 3 over 2. And the cosine is?
-1/2.
-1/2. So the 2's are going to cancel. Put the negative in front. So you're going to have negative radical 3 over 1. So just negative radical 3. All right? So everybody cool with using the unit circle there? Okay, so now we're going to plug in. So my final answer then is going to be, so the tangent of u, so that's 0. So 0 minus a negative radical 3 all over 1 plus 0 times, I don't care. Because it's going to go away anyway. All right? So then this is going to give me 0 minus a negative radical 3. That's going to be positive radical 3 over 1. So radical 3 is my final answer. So that's the exact value. All right, well, listen, good luck on your midterms tomorrow and Thursday. If you need to do a makeup, shoot me an email, but don't wait until the last minute, okay? If I can't do it, I can't do it. And then you guys have a safe spring break, and we'll come back and jump back into Chapter 8 on March 23rd when we come back.
Thanks, Mr. Strong.
You bet. You guys have a great day. Thanks for bringing all those questions. That was awesome.